and welcome back. Also, welcome back, dear audience, dear virtual audience. I've just heard we have over 1,200 guests online, which is amazing. And I would say, yeah, cool and fresh hello from inside the mountains. It's around 15 degrees, so it's a really cool breeze, and I've heard it's around 37 degrees outside, so I think we're in the right place here inside, right? And we are talking about a really cool topic as well.
We will have 5 startups up today.
Yeah?
Selected out of a crowd. So a jury selected these 5 startups that you will see in a minute pitching here for the Mars Habitat Challenge.
But what kind of startups?
So they're all innovative, technology-driven, and they have solutions to live on Mars in the future. So we heard that there was a jury pre-selecting the 5 startups that you will see and hear in the minute. It will be Mobot, Movusol, Robotics, Yasai, and Nematech. So 5 founders out of Switzerland will present their solution, how living on Mars will be the future, how could they support it. And it's my pleasure now to welcome our first speaker, Agnes from Mobot. Please join me on stage and tell us more about 3D automated printing in the construction.
15 years ago, I was working on extraterrestrial material, actually already on Martian meteorites. And I was dreaming about life on Mars. How will it look like? Today, I'm the founder of Mobot. We are offering automation and robotics of sprayed material. And I believe that this technology can be brought on Mars to help probably the colonization on this planet. Being it at the start for exploratory or for the colonization, we will need to build structures, first above ground and later on probably underground to protect us from radiation. We'll have the constraint to use locally available materials, which is Martian regolite. What is that? Volcanic rocks, very sandy material, actually even salts or hematite. This can be already found today on Earth. These are natural pozzolans used for construction materials. We'll need to use fully recyclable technologies, minimizing the energy used, and in a very fully automated process. Now, this is circular economy, right? Why not using this already today on our planet, on Earth? And this is what we are doing at Mobot. We are bridging 100-year-old technology, which is sprayed concrete, with new technologies like robotics, automation, sensors in a very integrated solution. On top of that, we are bringing our deep understanding of sustainable construction material, and we have developed a very good understanding of the aerodynamic of sprayed material, enabling us to to reduce the energy consumption. Today, our solution is a fully automated process, a system that enables to build underground concrete material, underground utilities. It's used for telecommunication network. Our end user can use, within just a few clicks, design their elements, which is sprayed, and delivered the next day on the job site, saving a lot of time, making it very simple, highly flexible, and bringing the work on the job site from 2 days to only 2 hours, saving on top more than 30% of CO2 footprint.
Thank you very much, Agnes. So you see, we are able to build and construct houses up there on Mars. And for that, we need also our next speaker, Dimitrios. Please join me, because we also need the material to build it together with Mobot, maybe. Tell us more about your startup, Movusol, and the smart material.
Yes, thank you, Stefan, for the introduction. So, hello, Hagerbach Next 50. My name is Dimitrios. I'm the co-founder and CEO of Movusol. You know, the first and biggest challenge to address when it comes to imagining a human base on Mars relates to the problem of payload. So currently, using SpaceX's Falcon Heavy, which is the most advanced and powerful rocket out there, humans are able to lift off only 63.8 tons of cargo if this is destined to low Earth orbit. But if we're targeting Mars, this goes down to only 16.8 tons. So this 16.8 tons could be, for example, a wall of 7 meters long of reinforced concrete, or it could be a 100 square meter room surrounded by clay bricks. So that would be the equivalent of cargo we can lift off nowadays from Earth to Mars. Of course, this is not enough to build a habitat on Mars. And to do that, we need materials chemistry. And that's what we do at Medusoil. At Medusoil, we develop biogeotechnologies inspired from nature, grown into laboratories, to eventually build more by using less. Our products are based on biominerals. These biominerals are grown from microorganisms in a fermentation process. So eventually, we are able to mix them with local soil, such as kaolinite or regolith, and eventually result into a fermentation process which can resist all the extreme conditions that the Martian environment poses, such as extreme temperatures as well as the presence of CO2. So we're talking about anaerobic conditions. At the end of the day, among the advantages of our technology, we have the fact that 90% of the final material is local, Martian soil. Only 1% of it is the binder, which eventually grows by itself. That's how we bring down the cargo load to few grams. This is the only first matter we'll need to lift off to eventually bring it to the bioreactor and multiply it non-stop. And yes, use Mobot's innovative head to spray it with local materials. So thank you very much for bringing together all of us. We need such bold visions to eventually create these nice collisions and collective imagination among us, and I can't wait to meet you all at the networking event later. Thank you very much.
Perfect timing. Thank you very much, Dimitrios. So we have built the first houses, and we know it's harsh condition on Mars. That's why we need our next startup. Peter, please join me and tell us more about Robotics, how you will do inspection out there on the harsh conditions.
My pleasure. My name is Peter Fankhauser, co-founder and CEO of Robotics. Isn't this beautiful? I would love to live on Mars. However, we know this is quite an inhabitable environment, and humans need quite some infrastructure and safety and an infrastructure to be able to live here. But on the other hand, technology today still needs humans to build this infrastructure. So what we have here is really a chicken and egg situation. What to do about it? Enter autonomous mobile robots. These vehicles have the capability to help us in threefold and colonize Mars. These vehicles first can be sent ahead to patrol these environments, explore and survey the environment to find the right spots to build infrastructure. Then we'll use concrete and other materials, and with the help of the robot to manipulate this infrastructure and actually build it up with these robots. And lastly, when the infrastructure is there, we can use the system to continuously monitor the environment for safety and make sure that the inhabitants of this Mars colonization is safe. So what are we doing on Earth? We're deploying these systems for inspection and maintenance tasks on industrial sites. The robots use legs to be able to walk through rugged terrain where typically only humans can go, and they're fully autonomous. Once installed, they take the sensors through the environment and gather data. This data is then on the robot analyzed and provides the operators with actionable insights on how to make sure their plants run sufficiently and safely. Here's a second example when we run the systems on construction sites. Here, the infrastructure is just about to be built, and it's very difficult to digitize this. Again, the robot with its intelligence going around, detecting the progress, checking if things are built right, and making sure that the operators there are safe. The value is clear. We can bring a robot with inspection sensors on top of it as a scalable inspection solution, providing the insights to operators to run the plant safely. And lastly, by reducing the exposure of humans to these environments, increasing thereby the safety. We're also preparing now to go to Mars, of course. What we're doing here with our partner at ETH is to add different capabilities. One is to send in the robot to unknown environments. You see here an example where the robot by itself just explores the environment and creates a very accurate 3D maps, and then coming back and providing that to the operator. On the right-hand side, an example of the work at the Robotics Systems Lab with a manipulator lifting objects and manipulating the environment. It was my pleasure to be here today. Thank you very much, and see you all on Mars. Thank you.
Thank you very much, Peter. So we talked about construction and also inspection. So what about food? I'm calling Philip from Yasai on stage. Please tell us more about the vertical farming and how you will be able to eat even on Mars.
Yeah, thank you very much for having us here. We are Yasai, and as you just said, we are growing vegetables, fruits, mainly herbs and leafy greens in our hydroponically indoor farms. So let's dive in by having a look at this really iconic picture, blue marble. And let's imagine a world where we can grow beyond our Earth and reach for the stars. Yeah, maybe not for the stars, but even at least for the planet next door, which happen to be Mars or the red planet. This, of course, presents us with the Mars Habitat Challenge, because Mars is indeed a very challenging environment, especially when it comes to food production. There are really harsh temperatures, gravity is different, and also the perception of time is not the same as on Earth. So what to do? How would you grow food on Mars? Firstly, of course, circular, for minimal use of resources such as water, oxygen, and nutrients, because it's a really limited thing. Secondly, we propose to do it underground because there are much more stable climate conditions and you're safe from the harsh environment of Mars, like storms, radiation, and other things. Here is an example of what we could actually do on the Mars. One point would be to use the wastewater of the station to get back the nutrients and grow fresh and new plants out of it. Second would be to get the organic waste, like complete organic waste, put it in a biogas plant, get new energy out of it, and again nutrients, because the effluents of such a biogas plant are really nutritious and can be used to grow fresh and new plants. Then secondly, as said, we propose to do that underground. Down here you can actually see an example which we did in Switzerland. It was a project to fill up a formal limestone quarry with a vertical farm. And yeah, this gives you a lot of advantages, such as stable temperatures, low radiation, and better security because you're really safe underground.
Thank you very much for your presentation. And last but not least, what happens if you need to repair something on Mars, but you forgot it down on Earth? Nematex, Raphael will show you how he can make 3D printing even on Mars.
Good afternoon, everybody, and thank you very much for the invitation to today's Hagerbach Next 50 Challenge. My name is Raphael Heb. I'm CEO and co-founder of Nematics, and in the next few minutes I would like to show how we would like to support sustainable Mars exploration. If we ask ourselves why should we even go to Mars, or how could we benefit from human missions on the red planet, we have to first familiarize ourselves with the conditions there. It's a very harsh environment with low temperatures, low levels of oxygen, and no surface water. So if we want to build a Mars habitat, we have to make sure to use the highest performing products and materials. On the other hand, there is no existing infrastructure on Mars, and the amount of material and equipment a crew can take with them to space is very limited. So this calls for very versatile and highly reusable materials. So overall, there's a lot of challenges and obstacles we have to overcome if we want to go to Mars. But nevertheless, we believe that building a Mars habitat will be a touchstone for sustainable production, teaching us of how we should use our resources more responsibly and also more efficiently. And for this purpose, we would like to offer our pneumatic 3D printing technology as a very versatile and highly efficient production solution in space. We are the first company in our industry to use so-called liquid crystal polymers for 3D printing, a material that has previously been used in space in the forms of airbags for Mars rovers or spacesuits. And our vision is that we recycle those products, convert them into 3D printing materials, and use microgravity 3D printers that allow us to produce complex-shaped, lightweight materials and products that can sustain in the harshest application environments. This would allow astronauts to produce highly critical parts on demand, from tubes to brackets, electronic housings, all the way to jigs and filters. And once these materials or products are not used anymore, they simply recycle them, reprint them into new products that are currently needed. On our road to Mars, we have performed the first step on Earth already. In a project sponsored by Space Innovation Switzerland, we have demonstrated basic space compliance of our technology. Based on these promising results, we have received access to a flight mission from the European Space Agency, which will allow us to expose our materials to the real space environment on the ISS, which will take place next year. After that, we would like to provide our materials and processes for in-orbit 3D printing. And our final goal is to actually close the loop and recycle redundant materials such as airbags or spacesuits, convert them into new high-performance materials, and support circular economy in space. With that, I hope I could show you how we would like to provide our products and services for sustainable space exploration, and I would like to thank you very much for your attention.
Thank you very much, Raphael. So you have seen now 5 innovative startup solutions for the Mars Habitat Challenge, and I'm asking now all the online audience joiners, please go now to the voting. You will see a poll online and vote for the most promising startup that you have seen in the last 20 minutes. And now I think we have the end result. Miriam,
yes, finally.
Welcome back, finally.
Yes.
Tell us more. Who is the winner of the first Mars Habitat? We have seen 5 great startups, so I cross my fingers for all 5.
Ladies and gentlemen, and the winner is from Robotics, Peter Funkhauser.
Congratulations.
Congratulations. Wow. How do you feel? Yeah.
For voting. Congratulations to everybody else. I'm sure it was a tough race. Thank you very much.
This is your moment.
Congratulations.
Thank you very much.
Thank you.
Michael, just tell us, how does it work now?
Well, we started this adventure with Venture Lab. We said, well, startups is extremely important for us here in our environment.
Yeah.
And I'm very proud of all of you, what you did, and to come here. Congratulations to the winner. The winner, what is the prize? The prize is, we always said, it's a proof of concept. So I'm looking really forward to define a key project we do together here in Hagerbach, together with Robotics. Congratulations.
Very much looking
So nice. Yes, congratulations.